So in this chapter, in this video, we're going to learn how to solve quadratic equations. The first thing I want you to look at here is what's called the zero product principle, which I have written right here. Let's see if we can think about what this means. If A times B equals 0, then either A is 0 or B is 0. Okay, that means if you have a product that's equal to 0, think about this. Some product, like right here, I call it the product A times B. If some product equals 0, then either part of that product can be 0, right? Because if A is 0, 0 times whatever B is 0. Or if B is 0, then 0 times whatever A is 0, right? Okay, so we're going to use that. So let's jump down to the quadratic equation. I'll talk about quadratic in a second. But look at this, what I have here. I got x minus 1 times x plus 5 is 0. So using that zero product principle, then either part of this product can be 0. That is this piece right here, the x minus 1, or this piece right here, the x plus 5. So what do we have to do? We set each part to 0 to get our solutions. So either x minus 1 is 0, or x plus 5 is 0. So basically we end up solving two linear equations. Remember how to solve these, right? If x minus 1 equals 0, what do we do? What's the algebra? Add 1 to both sides. And I get my solution, x equals 1. Or over here I'd have to subtract 5 from both sides and I get two answers for these. And x equals negative 5. Okay, so that's applying that zero product principle. And those are my two answers. Most of these are going to work like that. Okay, that is a quadratic equation. It might not look like it because there's no x squared term, but if I were to multiply these, I get an x squared. If you look at number 3, it's a little more obvious that that's a quadratic. Okay, so number 1 and 2, you'll notice they look like they've been factored. Number 1 and 2, in fact, already are factored, and the rest of these we're going to really have to factor on our own. Okay, that's what we'll do with most of them. Let's jump down to number 2 real quick. Apply that zero product principle. I said each part of my product is 0. So 3x equals 0, or x minus 2 equals 0. Solve this one, add 2 to both sides. X equals 2, it's one solution. Over here, don't subtract 3 from both sides, divide by 3. 3 times x equals 0. Then x should be 0, right? 0 divided by 3 is 0. Okay, those are the easy ones. Now the ones where we have to do some work. If the directions are to solve this equation, I need to factor it first. Okay, so hopefully we still remember how to factor. Remember, this is a quadratic trinomial. Leading term is x squared. So remember how we factored these in the last chapter. X times x to get x squared, then we need two numbers that multiply together to give you negative 6 and add together to give you negative 1, right? There's a 1 there. So it should be 3 and 2 as long as the 3 is negative. Okay, so the first step will be to factor. For most of the problems we do, first step will be to factor, and then we'll set each factor to 0. Okay, and then we have nice, easy linear equations to solve. Add 3 to both sides for that one. I'm running out of room here. That's x equals 3. Subtract 2 for this one. Minus 2 minus 2. X equals negative 2. Okay, moving on. Number 4, factor. Now this one isn't a trinomial. Alright, so we have to remember all our ways to factor. This has a common factor. Remember that 3-step list. Right, we should be looking first for the common factor. There wasn't one in number 3, but there is one here. It's 4x, right? I can factor a 4 out of 4 and 16. I can factor an x out of x squared and x. So I factored out the common factor, 4x. And I asked myself, what does that leave me with? Well, 4x times what gives me 4x squared? That's x. And 4x times what gives me negative 16x? That should be minus 4. Okay, that one looks a little bit like the difference of squares, but it's not. Once I factor the common factor, then it's not factorable anymore. So now I go on to my next step. I set each factor to 0. 4x equals 0. x minus 4 equals 0. And get my two solutions, divide this one by 4 to get x by itself. Come over here and write that answer. That's x equals 0. Okay, and this one I add 4 to both sides, right? So I get 4. That's my other solution. So those are my two answers there. And again, I didn't mention this yet, but we can check these, right? If I plug in either of these answers, it should come out to be 0, right? That is, if I plug in 0, plug a 0 in here, a 0 in here, I'm going to get 0. If I plug in 4, you should get the same thing. 4 squared, 16 times 4, 64, minus 16 times 4, 64 should be 0. Okay? So you can always do those checks. Alright, moving on. Number 5. 4x squared minus 25 equals 0. No common factor. This is difference of squares, right? So it's not a trinomial, difference of squares. We take the square root of 4x and it goes in the first spot, right? Remember this? And the square root of 25 goes in the second spot. So 5 and 5. One gets a plus, one gets a minus. Okay? And then I use my zero product principle. 2x plus 5 equals 0. 2x minus 5 equals 0. And I solve two basic linear equations. Okay, so let's start with this one. Minus 5, minus 5. So 2x equals negative 5. Okay, I'm running out of room here, but the next step in this one is divide by 2. Alright, so divide both sides by 2 to solve for x, and I get that answer, negative 5 halves. So I'll write that over here. Okay, and then solve this. I'm going to add 5. So 2x equals 5. So I get a very similar answer, right? 2x equals 5. And then I divide by 2, so I get positive 5 halves. And those are my two answers for number 5. Okay, there's one more video with about 4 more examples on it. Watch that one next.